Everybody is ready? So this problem, what is there? This is a typical example which we have generated for all of you. है ना? In which you have a slab depth of 150 mm. Load, the imposed load is given 5 kilonewton. That is your highest load in any structure which you do it, you know, live load. And column size is defined, 450 by 450. Concrete grade is given, steel grade, material grades are given to you. Base size is given, and it is a 5-story building. Okay. So now we are doing two things in this one. One is time history analysis, in which you can find the response. You will find the plastic hinge formation, sequence of plastic hinge formations. At any point you can see the displacement also, stress level also.
Stresses we can see.
Yeah, stress you can also see. Contours will be visible. No?
Contours
will be. And bending moment, shear force diagram also.
Yes, we can see.
So bending moment, shear force, all requirement you will can see. Okay. So entire this time is what about the frame you have you look for, it will be, you can see it all. Okay. And second part will be we have pushover curve. So whatever pushover you have been analysis is very important. So how the pushover curve is generated, you will see it. Okay. How the load is applied, how the load deformation will come, and how acceleration, that is spectral acceleration with the spectral displacement curve which we are taught, you can see it. So these are the applications. So these are the two problem statement, two problems, and these are the data which we are using. So it will go side by side. So first we are going time history analysis, na Sashi? So first is time history analysis. Okay. Okay.
We will generate both the cases simultaneously, but results we will see one by one.
Okay. So Sashi will speak, will run, and you also start saying. And this interactive board, all the things will be coming, so you can see what we are doing it. And this top, this one, middle screen, you will see the result and all things, what is new processing. Okay. So you can start now.
So basically today we are using the SAP2000 software, that is SAP Structural Analysis Program, the long form of this SAP, and it is developed by CSI America, that is Computers and Structures. It is mainly used for structural analysis and design for the different structures. Basically I have been using since 2008, my master's also, master's thesis also I have done on this, and even my PhD work I completed with this software. So analysis of structure like 2D, 3D structures, 2D, 3D frames, walls, shells, or pipes and plates can be done with the help of this SAP2000. There are other softwares also you might be aware of, ETABS and SAFE, that is developed by CSI America. So ETAB is entirely for the building, but this SAP has different modules so that we can use it for other purposes also. So today what we are going to see is, this is 5-story RC building we are taking for non-linear time history analysis as well as the pushover analysis. So basically this is 2 by 2 bay 5-story RC building, and base size is 4 meter by 4 meter, and the story height what we have taken is 3 meters. So this is the 3D problem, but what we are doing, we are considering middle frame for the analysis, because to reduce the time and the data space what we require for this analysis. And the material what we are taking is concrete of M30 grade and Fe500 steel, which is already available in the SAP2000. And the column size what we are taking is 0.45 meters by 0.45 meters. Basically I have earlier prepared the model and design check done for it. So the reinforcement is 10 bars of 16 mm diameters, and confinement reinforcement is 8 mm at 0.15 mm center to center. So the beam size is taken 0.3 by 0.45 mm. Slab depth considered is 0.15 meter. The loads are dead load and live load of 5 kN per meter square. So as told earlier, for the analysis I am considering the middle frame. So we'll start with the uh, procedure. So first, click to the new model. So this window will pop up. So here, what you have to do, you have to choose your units in which you are working and the default materials. There are so many options available. Uh, whatever units you want, you can work with, and materials from different countries for different grades. So there are so many options. We have the templates. Even without templates also, you can do the work. So there are blank, grid only, beam, 2D, 3D stresses, 2D, 3D frames, walls, flat slabs, shells, staircases, storage structures, underground concrete, solid model, plates and pipes that we can analyze by using this software. So today we are doing the 2D frame. So here it will ask for the data. So number of stories. So we have already seen we are doing 5-story building. Number of bays are 2. The story height is 3 meter and bay width what we have taken is 4 meters. So in addition to that, we have to define this beam and columns. So to define these beams and columns, we need to click this plus button. So this frame properties window will pop up, and we have to define this add new property. So here it is showing frame section property type for steel. We need to define it for the concrete. So here this concrete section, there are different shapes that we can work with. So first, that is, we are taking rectangular shape. So first I am defining the column. So the size we have taken is 0.45 by 0.45. Here you can see the material, that is M30, and you can see the section, but we need to define the reinforcement even. So I am entering into the reinforcement section. So here you can see we have the material over here, that is HYSD415. This is the only material available. We need to add the material. So I am clicking on this plus button. So I am adding the new material here. So once you click on add the material, you will get this region, material type, standard, and the grade. So we are defining it for India. So you have to choose region India. Then instead of steel, you have to choose rebar. Not steel. Steel is structural steel, which use for steel structure. So rebar. This is standard Indian, and we have to choose this HYSD grade 500.
Are you doing side by side or just looking at what he's saying? You are doing that? Yes, otherwise you will not learn it. This entire section has been made it for your learning. This effort has been made. Okay? So if you are slow, just
let me know.
Just tell him stop it. So he will stop and then you will go ahead. In case suppose it's fast, so if you want to slow down, you will slow down, but you go and doing what he's saying, and see there what is happening. Okay? Shashi, thoda sa slow.
Yes, sir. So you are now in this window. Okay. So I'm adding this HYSD grade 500. Then click OK. So we are again back on this window, that is reinforcement data. Till now it is fine. Is it okay? Yeah. So here you have to go for this FE500 for longitudinal bars as well as the confinement bars. Here you can see the options, that is column and beam. If you go for a beam, it won't take anything. If you go for column, you have to define this data. So this configuration is rectangular, our column is rectangular. So this is the clear cover, I am keeping it as it is, and we have the bar, 10 bars we have here. 3 means it will be like 8 bars, so I am changing it like 4 bar on one face and 3 on another. So here you can see longitudinal bar size. So you have to define the diameter of the particular reinforcement bar. So here you can even if you click the plus button, so here you can see different bar IDs and their bar area and diameters. So we need to choose what size of bar we have. 16 mm. So here you can see, here we have this 16D. This bar we need to check. So here in this pop-up menu you will get this 16D, and confinement is 8 mm. So this is 8. These are the number of legs what we have in the cross section.
Sir, why are we taking 16D and not 16 mm?
16D, 16 mm. I will show you. Just click on this plus button. Here you can see the diameters and bar areas. So here on this 16D you will find this 16 mm dia bar. Okay. This is fine. Then click OK. So you can see here. Now there are 10 bars what we have defined in the problem. Okay, this is about the column. Now again we have to define the beam. So again I have to click add new property again on the rectangular. In the section name I will write beam. What is the size of beam we have taken? 0.45 by 0.3. So width is 0.3 and depth is 0.45. So here material is again M30. See, now it is looking like still it is looking like a column. So we need to go into the concrete reinforcement and we change the material here, and instead of this column we have to click on beam. Earlier it was column, so we are clicking on the beam. Okay, so here that clear cover is there, so I'm keeping it as it is, so I'm clicking OK. Fine. So we have defined two sections, that is beam and column. So now in place of beam we will put the beams, and in place of column we will put the columns. Okay, done. No? Okay. So this frame has been generated. So whatever things we have defined, we can also define by using this define menu. Here you can see the material, the section properties, then soil profiles. Even you can define the coordinate system from here also. Load cases functions has been defined from this menu. Now we'll define the loads. So define, go to define menu, then click on load patterns. So here you will see one default load case, that is dead load. This is for all these materials whatever we have defined. In the material property it has the density, it will calculate itself, and it will calculate the weight. But for slab we haven't defined anything, so I am defining for the slab load case. Zero, because we are not defined the slab here. What the thing we have done is, so this is the 3D frame what we are analyzing, and this is the slab. So from here and here we are considering it this frame, the middle one. So from this way and this way, from the slab load is going, we are considering middle frame, because we need to simplify the process of analysis for the SAP, and it will take less time, so that we are considering only this frame. So load from this side and this side will also come. So load from this side of slab and this side of slab we need to consider. That's why I defined this case, that is slab loads. So that's why I am keeping this self-weight multiplier, that is 0. Okay? So I'm adding this case. Then the live load. These two cases I'm going to define. It may be 0. Because there is no self-weight right now. Only in one case date we have added the self-weight. Whatever materials or members we have defined, so their self-weight will be considered while analysis. Now we have to define the support conditions, that is these 3 supports. We need to give the fixity there. So here I am selecting these 3 joints or nodes, and then I am going to assign menu. I am going to assign menu. Here you can see the joint, first option. Straight. So here you can see the different support condition. In joint restraints are there. So I am changing it to this fixed. Now you can see the support conditions has been changed from hinge to fixity. हो गया? Now again, for this non-linear time stay analysis, we have to define the mass source. So I am defining the mass source, that is define. In that, mass source is there. In define menu, mass source is there. So I'm just modifying this mass source. So I'm clicking on this specified load patterns. Here you can see already dead load is there. So I'm adding this case. Then slab load is there. I'm adding, and live load is there. So I'm adding it at a 50%. At the time of earthquake, we are imagining the live load is 50%. That's why it is 0.5. Okay. And now we are assigning the loads. So choose the beams for assigning the loads. I'm choosing it by clicking. Now go to assign, go to frame load. With the mouse you can choose, just like this. Initially you do one thing,
After selecting what is to be done,
you will choose the entire structure, then go to assign.
after choosing the beams, what we have to do?
That is why I am telling. We have to go to the frame loads. That is in assign menu. There is frame load. You have to define the loads or assign the loads. Go to this frame load. Choose on gravity. So it is the load case has been given over there. That is dead, and the coordinate system is global. So in this SAP, the Z what we are taking is vertical direction. So -1, that is load acting downwards. So you can see here when I click the apply, this load has been applied, that is -1. Now we will choose these beams. There are several methods of selecting the members. One way is you can choose by using the mouse or clicking it. Then the second way is, here you will find the select menu. So in that select menu, there is a select option. From there you can go to the properties, the frame sections are there, and here you can choose either beams or columns. So these members has been selected. And there are one more method is, you can choose the select line parallels to. So there is coordinate axis or plane. So by choosing this axis or plane, you can choose the members. Okay, now again go to the assign menu, go to the frame loads, go to distributed. Here you have to choose the different load pattern because we have already defined the dead load. Now I am going to the slab load. So here you can define the load. Here load direction already has been given, that is gravity. So you no need to define or give the minus sign. So load what I am giving is 20 kilonewton. Okay, now you can see the loads. Okay, then again choose the beams. This time we will use the different method, that is select. Okay, again go to assign menu, select the frame loads, go to distributed loads, then again live loads. So I am giving 15. Okay. So you can see the value of change, load has been changed, and here you can see frame distributed load, that is live. If you want to see the loads, whatever you applied, you can go to display. Here, show the element, object load assignment. You can see the different loads. You can go to this display, show object load assignments, go to these frames because we have applied to the frames. Just choose the name of the load and click on apply or OK. You will see the load. So this is the load assignment. Now we will go to the defining of load cases. Then again go to this define. Here you can see the load cases. So whatever cases we have defined, you can see over here, and additional is there, that is modal. So you can find the mode shapes and the time period of the structure by using this modal analysis. So now we have to define one non-linear static case as a initial condition for the pushover analysis as well as the non-linear time history analysis. So what I'm doing is I'm adding a new case. That is gravity. So here you can see the load case type, that is static. So just click to this non-linear. And here you can see the load types, that is dead. I am adding this dead load case. Then this slab load, which is again the dead load. I am adding this one. And lastly, the live with the scale factor of 0.5. So this is the that is initial condition from which this earthquake or time history case will begin. Okay. Now we will define the hinges. I am selecting the beams. Again go to assign menu. Go to frame. Here you will see the hinges. These are the automatic hinges what we are going to define. Even you can define the separate hinges as per your requirement, but right now I am defining as per the codal provisions. So I am clicking on these hinges. So here you can see this auto option and relative to the clear length. So it will define the hinges at the particular length. So I am putting it on 0.1 L distance. So it is the relative length of relative of clear length. That is, I am defining at a 0.1 L distance. So I am adding it. So here you can see the ASE table. So I am choosing the table, that is 4113, and here you can see this is the type of members what we are going to choose. So here we are okay. So I am choosing this table, that is 10.7 for the concrete beams. So I am clicking OK. So one end we have defined, we has to assign it for another end, that is from another end, that is 0.9. We are adding two hinges at both ends. So there are two hinges, one is 0.1 and one is at 0.9 L. So here you can see the hinges have been assigned. Same way we have to assign the hinges for the columns. So I'm selecting the columns now.
सर for point one भी कर
एक तो ऑटो M3 दोनों ऑटो M3 है.
We are defining it for beams, that's why auto M3. साइन हो गए? नहीं. हुई?
After adding hinges,
2 hinges has been added. Then click on OK. Point 9. See, we are defining at the both ends. So 0.1L from this end, so 0.9 मतलब 0.1L from this end. Okay. So again I am defining it for columns. Same way, assign frames, hinges. So again I am adding the hinges. This time it is for the concrete columns. Just choose the appropriate table. 4113. Then for concrete columns. Here you will see more options are there. We have to choose PM3.
relative distance point one.
Point 1.
4113.
हो गया? नहीं नहीं नहीं, बीम पे 2 किए, कॉलम पे 2 करें. Again for 0.9. Remember this is PM3 for columns. For beams it was M3 only. And PM3 because we are doing the 2D analysis. 2D. चेक करते हैं, दोनों हो गए.
0.8 और 0.9 दोनों.
Okay, so here you can see 0.1 and 0.9 for columns.
पहले वाले दोनों बीम के लिए थे और ये दोनों कॉलम के लिए।
That's why it is auto M3 and this is auto PM3 क्योंकि उस पे एक्सियल लोड भी आ रहा है कॉलम पे. So here you can see जो सर ने बताया था, यहाँ पे तुम hinges देख सकते हो.
वही तो नहीं आ रहा है। अबे गवार आदमी।
ये देख सकते हो, you can see जैसे सर ने बताया था, these are the hinges that you can define. नहीं, this is different. You have to define both the hinges simultaneously. Simultaneously मतलब one after another in the same year. See, once you choose this member, just go to assign, choose the frame, go to hinge. Here you can see two hinges.
हमारी सीट हर बार डिफाइन करने जाते हैं, हर बार हमको क्रिएट करना पड़ता है.
टेबल 7 ये जो ओके क्लोज अप्लाई वाले ऑप्शंस है ना, ये शो ही नहीं
It is because तुम्हारा resolution अलग होगा. स्क्रीन हाँ, वो नीचे जा रहा होगा स्क्रीन के ना,
हाँ, वो कैसे सही करेंगे सर?
उसको रेजोल्यूशन चेंज करना पड़ेगा तो विंडो छोटी हो जाएगी. रिप्लेस करोगे तो रिप्लेस हो जाएगी.
अरे हमको सिलेक्टेड व्हील नीचे ये कैंसिल अपना है, वो दिखने चाहिए। कॉलम दे रही
Can we move? No, नहीं हो.
Okay, नहीं लाया हुआ.
कॉलम कर कॉलम
रिलेटिव लेंथ करो.
और एक पॉइंट 9 पे
So this is about the adding hinges. So you can see the interface something like that. Now we need to choose the hinge override application. This is because sometimes what happened that hinge length is overlap on one another. So we need to choose this hinge override. So you have to choose entire structure. You have to choose entire structure go to this assign menu, go to frame and go to this hinge overrides. Okay, so here you just click on this auto subdivide parameters, that is, and click on this button. Okay, click OK. So it has been assigned to entire structure. So we'll do the initial analysis. It hinges override.
Yes.
We'll go to the set analysis options. So we are going for this plane frame. Right? One second. Go to analyze, set analysis options.
hinge overrides करो assign में जा
Click on this plane frame. Click OK. And again, go to analysis. Click on run analysis option. Click on run analysis. Go to analysis, run analysis.
अरे इनका देखेंगे ना exit only select करो
You can see the cases over here. Set analysis option, 2D frame. Okay, okay karo. Then go to analysis again and run analysis. Here you can see this window and run now. Before that you have to save this model.
just run now ना
But you have to save this model. When you click on run now, this window will pop up, that is save model option.
And look and rerun analysis. Hinge property due to be regenerated
Oh yeah. Here you can see the deform shapes. That is for dead load. Here there are three options. That is, you can see the deform shapes and the forces. So here in deform shapes, you can see this three or the modal analysis. So this is mode 1. You can see the time period and the frequency. Then in this below, in the bottom corner, there are two options. By clicking this, you will move to the mode 2. I'm just switching to this XZ view. This is the second mode, and this is the time period and the frequency. So for this non-linear time history analysis, you need these two values, that is time period for first mode and the second mode. Just note it down. Just note it down, this time period. Because for non-linear time history analysis, we have to put these values for the damping. XZ में जाओ. first mode and the second mode. And this is the third mode. Hmm? Oh, third mode. That is third mode. So noted the time period. So now we will check the output. Go to this display option. Go to display option. Display option. Go on show tables. On show table, display option, show tables. So here you will see the structure output. You have to click this plus. You can see the model information. You just click on this modal load participation ratio and modal participating mass ratios. ये दो, just click on this second and third, modal load participant ratio and modal participating mass ratios. Okay. Now we will see the mass participation of this. As sir told in the presentation, that is around 80% mass has been distributed in first mode. So the mass participation.
सर मैच हो रही है
नेगेटिव आ रहा है
सर ये जो UX है ना हमारा 0.79 की जगह 0.82 आ रहा है.
There might be something different in assigning the properties. यही थोड़ा difference हुआ होगा बस. Period same है. थोड़ा difference हुआ होगा.
79 आ रहा है हमारा 0.79 आ रहा है. ये तो 0.81 आ रहा है.
कहाँ?
ये UX यूनिट टेस्ट वाला तो पॉइंट ये हाँ 0.81 आ रहा है 0.812
0.7975 आ रहा है
ठीक है.
ये वैल्यू अलग आ रही
सर
है.
हमारी वैल्यू अलग आ रही है.
कहीं कुछ थोड़ा सा difference हुआ होगा.
यूनिट आ रहा है 0.82.
ठीक है, कोई दिक्कत नहीं. In first three modes, it should be like 90% mass participation should be there. So if you add these three modes, there will be a 90% mass participation.
इनमें मुझे कौन सा कुछ नहीं किया इनके
सर बट मैच तो करना चाहिए.
थोड़ा सा difference हुआ होगा.
हिंज का होगा
सर हमारा तो टाइम पीरियड भी अलग है. मोड 3 का टाइम पीरियड और फ्रीक्वेंसी तो हाँ फ्रीक्वेंसी भी अलग है.
टाइम पीरियड अलग है तो फ्रीक्वेंसी तो अलग होगी.
कहीं कुछ मॉडलिंग करते वक्त थोड़ा चेंज हुआ होगा.
लाइव लोड को 0.5 किया था
कोई दिक्कत थोड़ी है.
अभी तो नहीं.
कोई दिक्कत नहीं, असली में है.
Then
इसके बाद ओके कर देना है.
we need to check the design. So go to this design menu. Go to concrete frame designs. There are the preferences, that is view and revise preferences. So here you have to change.
सर एक मिनट वापस बताना. डिजाइन में जाने के बाद
View and revise preferences, concrete frame design. So you have to choose this Indian code IS 456-2000. Okay. Then again go on design, start design, or check the design of structure. Okay, it will show the capacity ratios. So it should be like below 0.7. इस रेंज में होने चाहिए. Again, you can check with the help of this verify all member passed. So it will show if anything is not passing, so it will show the particular member. Okay, so this is design part is over. That is, our model is ready for next procedure. So we'll move to the non-linear time history analysis now. So first you have to unlock the model. That is this lock button is there. You have to unlock it. Then go to this define menu.
अनलॉक करने के बाद
Go to define
फाइन गए
functions, time history. So here this cosine function is there. You have to choose this from file. Then add new function. ठीक है? Then go to browse. Earlier one file has been shared with you, so choose that file. This one. You have this file.
सर वेट एक मिनट
After from file, click on this browse.
Error in reading time.
You have chosen this file. It is showing error now, no?
Open करने के बाद what we have to do?
See, the header line to skip ऐसा कुछ लिखा है. Something has been written like that. So if I click the file,
अच्छा जो empty line है वो line number
you have to skip. This is the file which has been shared with you. So basically this is the file that has been converted from original data which is taken from peer website, peer ground motion website database. So it is converted, that data has been given in terms of G. So it is converted to meter per second square because we are working in meter per second square, and it is converted to absolute for 1G, absolute 1G. So by using this file you can apply the different levels of PGS. So it is converted accordingly. So here you can see 1, 2, 3, 4, 5, 6, 7 lines you have to skip. Now click on display graph. So in that file you can see this interval also, or not 5 seconds. So it is as it is. I'm not changing it. So this is the function. So here you can see the time, that is around 39.99 seconds. You see that file. So those many data points are there in the file at this interval, that is 0.05 seconds. Okay. Changing the names. That is the name of earthquake. Okay. Shall I move further? Okay, so this function has been defined. I am clicking this. Okay. Now, again go to define menu. Go to load case. We have to add new case. Time history I am adding. Here instead of static, you have to go for time history. Solution type is direct integration. Case is non-linear. And we are starting it from this gravity load, what we have defined earlier. So here, instead of load pattern, you have to choose the acceleration in the direction of u1, and this is the function what we have defined earlier. So if you scale it at a 1, so it is around 1g. So I'm just scaling it at 0.4, and then you have to add it. So you can see here the time step data. So number of output steps, it is 100 and time step is 0.1, but we have 39.99 seconds earthquake. So what I'm doing is I'm putting the time step of 0.01 seconds. So if you divide it 39.99 with this 0.01, how many steps? यहाँ से. So there are different load case types. You have to choose time history. Earlier defining. Wait. Done? How many steps? 3999. 0. Again, here we have to click on this geometric nonlinearity parameter, that is P delta. So we are considering the material nonlinearity here and geometric over here. Okay. So this is one function defined. Now this is the time history, nonlinear time history case. I am now defining the pushover analysis case. So this is again static case. I am defining it as a non-linear. It is again continue from this gravity load case. I am now defining the pushover case. So here instead of load pattern, again acceleration has to be given. This is the scale factor you have to choose, -1. Okay, done.
Sir, how is it from the non-linear static?
Non-linear static. This one. I'm choose this. Now go to this load application. We are going to displace the building, so we are moving into this displacement control. and it will be a monitor displacement. Usually it is 0.4% of the building height. So our building height is 15 meters, so it is 0.6. What happened? This one? This load application, okay. So we have to move this in this modify show option. Instead of we are displacing the building, so that's why I'm moving into the displacement control, and this is the monitor displacement I am moving into, and this default value is there 0.6, so it is 0.15% of the building height usually it takes, and it is giving the displacement in the U1 direction at the joint number 6. It is the topmost joint. Okay.
At joint पे 6 है.
Then result save, we have to go to this option. It will save final stage only, so we have to move it to the multiple states. So here you can alter the number of steps which would be saved. So it will show the results accordingly. Okay. This is again P delta. I'm clicking OK. So this is time history and this is pushover. Both the cases have been defined. Okay. One thing is left, that is we have to define the damping. Again go to the load case, go to this time history, again go to load case, go to time history, go to modify. I'm again open the time history case through the modify menu, because we need to define the damping whatever we have noted earlier, time periods. So accordingly we have to define the damping. This is the time history, whatever we had defined earlier. I'm just modifying it for the damping, because damping it is none. So all are here. Okay. So modify and show damping. So here we have to specify the damping by period, whatever earlier we have noted. So I'm clicking on this menu. So it will ask for the period of first. Huh? Okay, here damping. We have to click on modify and show. Okay. Then click on this specify damping by period. So what is the time period we have noted earlier for first mode and second mode? 0.7571. And for the second?
0.236.
0.236. Okay. And damping value what we are giving is 0.5, that is 5%. 0.05. Okay. We will click on recalculate coefficients. So it will take the damping values like this. Okay. So put the time period whatever you got earlier for your model. Hmm? I am clicking this OK. So here now changes to the proportional damping. Okay. Now go to this run analysis and run the analysis. It will take some time.
इसको ग्रेविटी का
ये टाइम पीरियड लिखने को कहा था ना, लिखने को
अरे नोट पैटर्न का एक्सप्रेशन का ये सारा कुछ इसके डेवलपमेंट
Okay. This is over. You can see the hinge formation is there and you can see the states of the hinges. Here you can change this hinge state colors like for B, C, D, E, or this is immediate occupancy, life safety and collapse prevention.
सर ये कैसे improve कर दिया?
See, you can see deform shape over here.
Yeah, I did that.
Huh? Then I am going at the 20-second time. Then here you can see the hinge states. So you can choose either this option or this option. Huh? Okay. So you can see the hinges and the colors. If you want to move further, you can, by clicking this, you can move further in the time. So this is, you can see the displacement over here for that particular step.
सर ये hinges के लिए क्या follow करना है?
ये show तो नहीं हो रहा।
ये deform shape जाना है. Then I am defining some time. Initially you can see there are no hinges, but as this earthquake progresses, the hinges will be formed gradually.
अरे हमारा तो बहुत पीछे टाइम 20 इयर्स के बाद पीछे जा रहा हूँ कुछ तो हम डिंगर रोकला था
Okay, this is about the time history, and you can see here in display static pushover curve.
सॉरी बोल देना
So this is ATC 40 capacity spectrum, and this is pushover curve.
बता दो तो बस क्या ही होगा तेरा
display static pushover curve.
तो वो जो आदमी ग्रे हुआ
सर थोड़ा सा इसमें वो टाइम से कुछ और लोड जैसे बनने वाला है
ऐसे ही करके जाएगा
दोनों इनके ऊपर एक बार मॉडिफाई करके बता
अभी गायब हो गई थी अभी तो नहीं लगा रहा था नीट के चक्कर में तो नहीं हो रहा
मॉडिफाई कर देना बना दो शायद बना नहीं बिना इंच के डिफॉर्मेशन
ऑप्शन ही ओपन
इन लोगों ने ही जो ने डाल के करे थे सर पर एनालिसिस के बाद इन लोगों ने हो जाता है
इसमें फिर चेंज करें
तो मैं वापस से अनलॉक करके करूँ चेंज
टाइम पीरियड क्या है आपका?
दूसरे वाले का टाइम पीरियड क्या है
मॉडल सेलेक्ट
सेकंड में सर 0.236 टाइम पीरियड
हमारा ड्रॉप आ रहा है इसमें ड्रॉप नहीं आ रहा
ड्रॉप आ गया ना आपका?
पर इसमें तो नहीं है
उसमें थोड़ा टाइम लग रहा है, ये बढ़ाना है डिस्प्ले।
टाइम पीरियड है ना अब रन करना
और कुछ पेज में
यस सर।
So give a applause to the Shashi here. Very good job. Are you benefited by him? learned something? Okay, good. So well done, Sushil. Because he